Hello! Welcome to the first episode of Women in Astronomy. I'm Paula. In this series, we'll be highlighting some of the important discoveries and contributions made by women to the fields of astronomy and physics. In this episode, we'll learn about the so-called Harvard computers and how a group of women had a huge influence on modern astronomy. They documented and classified hundreds of thousands of stars, discovered thousands of variable stars and other celestial objects, created our modern stellar classification system, discovered relationships between stellar properties, and so much more. Let's learn more about some of these incredible women. In the late 19th century and early 20th century, dozens of women worked as computers at Harvard College's observatory. This was before the computer that we know today existed. During this time, the term computers referred to people who did calculations. These women would look at photographic plates of the night sky and compare them to other plates to learn more about the stars, just like this woman's doing right here. This job wasn't exactly something that astronomers really wanted to do. The process involved long hours and was tedious, repetitive work. Because of this, the job went to women who had limited options for employment in astronomy. These women were underpaid, making between 25 to 50 cents an hour, which is less than a man would have been paid during this time for the same work. At Harvard College Observatory, male astronomers operated the telescopes and took photographs of the sky at night, while the women examined the photos, did several calculations for stellar data, and classified the observations during the day. The first female computers were hired to work at Harvard College Observatory in 1875, and the team would grow to include dozens of women. One of the first projects that this group of women worked on was the Henry Draper Catalog Project. This was a long-term project to gather the spectra of many stars and classify and organize them by their spectra. These spectra show how bright celestial objects are at different wavelengths. The project was supported by Mary Anna Draper after her husband Henry Draper passed away. At Perry, we have a collection of plates like the ones the Harvard computers looked at. This is where we keep some of our plates, and this is what a photographic plate looks like. These photographic plates are important because they are a snapshot of the sky from the past. These plates hold a piece of history. By comparing older plates to more current plates and our current sky, we can see changes in the stars that we wouldn't have noticed had we not had a record of the past. Here at Perry, we have plates from all over the world. The first woman we're going to highlight is Wilhelmina Fleming. Wilhelmina Fleming was one of the first computers at Harvard. She worked as a teacher until her husband abandoned her and their son. After this, she started working as a maid for Edward Charles Pickering, the director of the Harvard College Observatory. It's said that when Pickering became frustrated with the men who worked at the observatory, he would say that his maid could do a better job than them. Eventually, his maid was hired. Later in 1879, Elizabeth Pickering, the director's wife, recommended Fleming to work part-time doing administrative work at the observatory. In 1881, Fleming officially joined the Harvard College Observatory and learned to analyze stellar spectra. Wilhelmina Fleming was put in charge of the Henry Draper Catalog Project. Fleming came up with the idea to classify stars by the amount of hydrogen in their spectra. This became known as the Pickering-Fleming system of classification. Fleming discovered dozens of nebulae and hundreds of variable stars during her time at Harvard. One of her most notable discoveries was the Horsehead Nebula in Orion. However, she was not credited for many of her discoveries at Harvard College Observatory until 1908 when the second Dreyer Catalog Index came out. Before this, many of these discoveries were attributed simply to Pickering, and it was not until later when Fleming and other women gained some notoriety that they were cited as contributors. Wilhelmina Fleming had no formal background or education in astronomy, but she still had a huge impact on the field. This is Annie Jumpcannon. Annie Jumpcannon was a specialist who had a degree in astronomy and physics from Wellesley College, the school I go to. As a child, Cannon's mother taught her the constellations and encouraged her to pursue her passion for science from a very young age. After college, Cannon was introduced to the Harvard College Observatory, and she was hired as a Harvard computer in 1896. She was known for her ability to look through spectral plates and classify stars very quickly. She manually classified around 350,000 stars, discovered 300 variable stars, or stars that can change brightness, and 5 novas. Cannon could classify up to 3 stars in just 1 minute, just by looking at their spectral pattern, and she was super accurate also. She could classify stars down to the 9th magnitude, which is 16 times fainter than the human eye can even see. Cannon also worked on the Draper Project. When debate arose as to how to classify the stars, Cannon proposed her classification system, which organized stars by temperature from hottest to coolest, and used letters to organize the stars into groups. You might have heard of O stars or B stars. That's from Annie Jumpcannon's stellar classification system. From hottest to coolest, the order of stellar types are O, B, A, F, G, K, M. Our sun happens to be a G star. We still use a stellar classification system, to this day. Along with her many discoveries, Annie Jumpcannon was the first woman to get an honorary degree from Oxford University. She was also nearly deaf for most of her life, but she didn't let that get in the way of her passion for astronomy. Another notable woman was Henrietta Swan Leavitt. She studied astronomy at Harvard and was hired in 1907 to look at variable stars, mostly in the small and large Magellanic Clouds. She found around 2,400 variable stars by looking through thousands and thousands of photographic plates, laying them on top of each other and comparing their brightnesses. While looking at the plates, she discovered a direct relationship between periods and brightnesses of some Cepheid variables in the small Magellanic Cloud. Cepheids are variable stars that get brighter and dimmer on a regular cycle. Leavitt measured the period of each star, or the length of time each cycle takes. From these measurements and calculations, Leavitt discovered that the period of a Cepheid is constant and directly related to its brightness. So the brighter the Cepheid, the longer the period. Also, if you know the period of a Cepheid, you can calculate its brightness. This period-luminosity relationship became known as Leavitt's law, and it's very important to astronomy because this made Cepheids act as standard candles, or objects with known luminosities, that help astronomers make measurements and compute distances. Leavitt's discovery forever changed how we see our universe by allowing us to calculate how far away distant objects are, like galaxies. This laid the groundwork for our modern understanding of the structure and size of our universe. An astronomer named Edwin Hubble and several others used Leavitt's period-luminosity relation when calculating the expansion rate of the universe. The women I talked about were only a few of the women who worked at the Harvard College Observatory. There are many more. Women throughout history have made significant contributions to science and astronomy, despite obstacles, and many have not had their stories told. I encourage you to do more research to learn more about these women and other women who worked as computers at Harvard College Observatory. The Harvard computers were definitely underappreciated during their time. They were not allowed the same opportunities to observe or do the work that men were able to, but they were still able to make great discoveries that changed the field of astronomy. Many of them had other women who supported them and helped them to achieve their goals, so it's important to continue to support women in astronomy. I hope you had a good time learning about some of these incredible people. I'll see you in the next episode of Women in Astronomy. Bye!